Ray Times at the Cycles Research Institute. What does this talk about?
It's about the 17-week cycle in the United States stock market.
Yes.
Edward Dewey made a particularly comprehensive study of this one, and he determined the cycle very accurately by following it through. Now, what I'm showing here is from 1936 to 1950. It's got 3 years, 3 years, 3 years, but he actually followed it through some 100 years or so.
Yes.
He used a filter to combine multiple cycles because it doesn't show that clearly on its own. But if you filter a few cycles together, if there's any odd stuff in one or the other, it tends to cancel out and you get a clearer picture. So this is a result of his filter, which is producing this. And most of the time it's very clear. You can count the cycles, you can follow them, you can say it's a few extra little wobbles, but it's quite clear that's one, that's the next, that's the next. There's the odd place where it goes a little bit unclear and you're not quite sure.
Yes.
So now Dewey's got page after page of that graph, and then he does his analysis. He also does it in sections, different parts of the period, to show that the period doesn't change very much from one section to the next, and the phase stays the same. So he's saying this is a regular, consistent cycle over a long period.
Because the phase is consistent.
Yeah. Now, what I've done here is this is my analysis of his data that he provides, and I'm going from the beginning of the period to the end, and we'll better give you the date for that. But it's at each point, this is the number of weeks of the year.
Yeah.
And I'm plotting when the peaks were through that year.
Yeah.
And you'll see that that we can find 3 peaks in each year. In this case, this one came earlier in the year, so I've put it later in that year because that's really part of that one, right? It's wrapping around to next year.
Yes.
So we've got these 3 peaks, and they're all moving in a similar way. It's quite clear there's a consistency across the whole thing, but there's definitely some modulations going on, right?
Yeah.
So we've got the 3 peaks there. I established that by putting the actual dates and weeks of every cycle through the whole period. And then what I've done is I've said, let's combine the 3 of those, put the 3 of them together on the graph, and then take an average of the 3, make a composite, which is showing the phase of that cycle through the entire period.
Yes.
Now, that graph, we can notice a couple of things about it when we do it. First of all, it wanders about on a very long cycle, approximately 23 years.
Mm-hmm.
It also has a shorter term backs and forwards, earlier and later, 5.95 year cycle.
Yeah.
That's not, it's interesting because the blue ones is a perfectly regular 5.95. We can see that it starts off correct on those couple and it ends up correct here, but in the meantime it comes a little early here, about right there, and a little late there. So there's some modulation in that direction as well as in this direction, right?
Yes.
So, but we've got this thing. So this data runs from 1898 to 1959. So we've got 61 years of data.
Yes.
And so it's interesting to follow that through there. Now, this is my analysis of the period. When I looked at Dewey's data, I found that there's one place where the cycle got very weak. And when I look at the phases on that diagram, he actually slipped from one of those ones to the other one. It sort of went down a bit and he picked it up again. And I think he'd got one account of one wrong in the number of cycles there were in the whole period. So he gave a period of 17.166 weeks, which is 0.3309 years. I've corrected that by one count, and that gives 0.3291 years.
Mm-hmm.
That would be adjusting his one by one. When I do the cycles analysis through the whole thing, my best estimate is 0.3292 years. So he didn't get much different if we allow for the one cycle that I think he counted wrong.
Yes.
From the harmonics theory, we would expect, in relation to all the other ones we've got, 0.3287 years. So it's slightly different to that, but not very much. Oh, sorry, that's using the harmonics theory based on Dewey's 17.75 year period.
Yep.
And based on my period, I get that. So those two are spanning that either side, so it's perhaps somewhere between the two, right?
And yours is 17.793 as opposed to Dewey's 17.75.
Yeah. So we're surrounding that. The difference is already in the last place. Now, another interesting cycle, when Dewey mentions these 0.33 years and 0.66 years, or if we like to call them 4 months and 8 months, as very common cycles, and they appear in many, many different things. One of the things we might suspect as a cause for that is the Jupiter-Venus conjunction period, because these are the two planets that have the biggest tidal effect on the Sun.
Yes.
In that case, we get 0.3244 years as the period, and it's quite obviously different from these.
Yes.
Now, I've actually put a figure up here, and I'd rather perhaps just ignore that bit and say that if we take that one and what's probably the best estimate of this cycle and consider those two, 0.3244 years and 0.329 years, we can look at what's the peak period between those, and the answer is 22.2 years. Sunspot cycle.
Yep. The 11-year and 22-year sunspot cycle, and it's often 11.1, 11.2.
Yeah. Now, you remember that when we did there was one of the other ones where the lunar month showed up, not the actual month, but two figures just a little bit either side, and that the beats between those showed the 22-year cycle as well. Now, in this case, I think what we've got is that we can say it might be being caused by the Jupiter-Venus conjunction period, but each time the Sun flips its poles, it changes, the phase changes, so it gets a half a cycle different. And when it flips back, it changes by the other half, it gets back. So we end up with this period.
Yeah.
And so it may be that it's related to this and the sunspot cycle in combination. This will be why it's sometimes hard to find things, because you get these modulation effects. The fact that the Sun's pole is flipping in conjunction with that is showing up perhaps in the stock market in that way. So anyone who's just using that thing there will get the wrong answer. It will work if you just do it for 10 years while the sunspot cycle is one way.
Yes.
You'll be fine. Someone else does it another 10 years, will be fine. Their answer will be different to yours. And if you do it for the whole thing, you're going to say, nah, just misses it, so close. But we can't say that's definitely the case, but it's so close that when I used that period and the best estimate there, it gave 22.2, although the accuracy would only be plus or minus more than 0.5 or 1.
Yeah.
I put a 23.7 here, which is the beats between that with a different one, but that's probably the wrong one to use. So that's stock market, that particular stock market cycle.
It's fascinating.
It's if we were to use the this diagram, we can project into the future or into the future, and it's just basically extending this. So we can see there is a general up and down move, and then there's the shorter term one here following the green line up and down.
Yeah. Marvelous.
Yeah. And again, the 5.95 is very close to half of Jupiter's period around the Sun.
Going into the same divisors again.
Yeah. So that's Dewey's 17-week cycle in the stock market.
Thank you, Ray.
There are, in another case, a guy named Castles did a report on the 40-month cycle in the stock market, and he found it was modulated by the sunspot cycle as well. So
another case.
Another case, yeah.
Thank you, Ray Times at the Cycles Research Institute.
This was just a bit of hand scribble one I did. It's looking at a period from before 1900 to 1960, and it's the 17-week cycle in the Dow. And this here is the phase of Dewey's cycle.
Yeah.
Right? But when I repeat that again, up a bit and down a bit, what I see is that Dewey missed a beat. Because what we're actually seeing, if you follow this one up here, it heads on perfectly into that one, doesn't it?
Yes.
This line carries on through there.
Yes,
and so here, although he followed the closest one in each case, I think the correct thing should have zigzagged from one of these to one of these and carried on. And that's why I gave a talk before to you where there was a count of one difference in Dewey's cycle, and I arrived at a slightly different period because of that. So it's only a hand-drawn sketch, but it makes it clear
Yes.
why I did that.
Yes, indeed.
Yeah.
Ray Toombs of the Cycles Research Institute, thank you. We're talking about 71, what is it now?
71-year cycle.
71-year cycle in stock market prices. Is this in the United States?
Yes. So what we've got here is a graph comparing the Dow Jones from 1929 onwards and the NASDAQ from 2000 onwards. Sometimes people thought that 2008 was the key point, but in actual fact, when we look at it, the 2008 peak is not as high as 2000. I think this might be inflation adjusted, but I'm not quite sure. But it's clear that when we look at the Dow back then and the NASDAQ more recently, there's a great deal of similarity. We line them up there.
Yeah.
The difference, 29 to 2000, is 71 years. One of Dewey's stronger cycles. And the harmonics of that, 35 and a half years, 17 and 3/4 years, 8.88 years, 4.44 years, and many others are all strong cycles. So
Yes.
no matter which cycles we're looking at, they're synchronized after 71 years. Very, very big proportion of cycles that affect the stock market are synchronized after 71 years. So we do see this great similarity
Yeah.
in the dive here,
It's striking.
even to the little bumps. And then again at 2008,
Yes.
they both take a dive again. So this was done some years back,
Yeah.
and the idea was somebody's put Fibonacci retracements in as well. I'm not such a big fan of those, but if people like them, they can do them. So this was perhaps going to give some indication of what was going to happen next.
Yes.
We looked at a couple of graphs comparing the Dow Jones from 71 years before with the NASDAQ. This is an alternative version of that, which goes back a little bit further to the run-up to them. And we can see that there are a lot of similarities. Now, the difference here of 71.12 years, it hasn't been done exactly perfectly to line up the tops. It's been done based on the periods of the cycles that I've seen the pattern in: 71.12, 35.56, 17.78 years, etc. Slightly different to Dewey's period, not very much, but the periods that I think are the best fit to all information that we have. And when we do that, we see both of them coming down together.
Yes.
A little bit of differences here, but then somewhere here, they both start to take off to this big climb. They do one little bounce on the way down,
Yeah.
and they go into a deep trough. They do one bounce in the trough, then they come out, and then again a dive here. This is going up a little more than that, but it's very similar. And what we do know is if markets are made of the sum of many cycles, then very many of those cycles are fractions of 71.12 years.
Oh.
Because we can divide that by 2 repeatedly: 35.6, 17.8, 8.9, 4.45, 2.22, 1.11. We can divide that by 3, which is 23.7 years, and then keep dividing by 2: 11.86, 5.93, 2.96. They're all common cycles: 1.48, 0.74 years. We can divide it by 3 again from the 23.7, and we get 7.9.
Mm-hmm.
We get 3.95, 1.975, 0.99, 0.495. They're all common cycles. We can do it again. We get some more. So there's a huge number of the common cycles
From common harmonics.
that come from this one.
Yes.
There are a few that don't,
Yeah.
but not very many.
Yeah.
And so we expect it to be fairly similar there. If it wasn't, there'd be something wrong with saying all those cycles are common in many things. They're not identical. They're not identical. So there are some other cycles that are not fractions of these. They're longer periods that have got some harmonics that are not related exactly to these and that are causing some differences. But we can look at those things and we can say, yeah, history's almost repeating itself. Not quite.
71.12 years.
Yeah.
Ray Toombs of the Cycles Research Institute. We're going to talk about IBM share price cycles. What do we have, Ray?
Okay, so this is a bit of a different process for looking at cycles. The first thing that was done was I took the share price of IBM, I think it was daily prices, from 1962 to 2010. And when I did analysis of it for cycles, I took the 67 strongest cycles that came out of it. So
Yes.
there's lots of cycles. I don't really want to run a projection based on those. It's too many. So what I did instead is I took those 67 cycles and I ran them through this Kotov method of looking for communalities. So we did that already with the distances of the planets from the Sun, and we found it did find some interesting structures.
Yes.
So in this case, we took all the 67, put them into the program to do the Kotov analysis, and we got this graph. Now this ranged from 1 day to something over 100 days. And this shows how strongly any particular period, in this case say 10 days, commutes with all of those 67 cycles.
Yes.
And what we see is we get a bunch of peaks. But the fascinating thing about it is this peak is at 2.5 days.
Yes.
This peak at 5 days.
Yes.
10 days. A little structure around 20 days. 60 days and 120 days. And we can see quite clearly these are at a ratio of 2, 2, 2, 3, 2. Typical harmonics theory structure of ratios of 2 and 3.
Yes.
These periods also, the 120 days is 0.33 of a year that Dewey mentions as one of the common cycles.
Yes.
What's his name? Gann.
Yes.
Used periods, and he talked in terms of degrees, 360 and 120 and all this. They actually were days, and he uses these periods. Hurst uses these periods,
Yes.
right, in his cycle. So the cycles themselves were there may have been groups at some of these, but there were lots of other cycles as well. But all the other ones tend to be, if you've got a 15-day one, it would have been a quarter of a 60, right? And so on. They were related to these, and there might have been a 12.5, which would be 5 times this one. There were multiple. They tended to be multiples or fractions of these values, or these values themselves.
Yes.
But there were a lot of other cycles there. They weren't all that. I clearly didn't have 67 cycles just on those 5 values. But the 67 all related to these 5 values, or mostly related to these 5 values.
Interesting.
So I'm not quite sure how you use this to make predictions, because you can just run those individual cycles, and there's probably some value in doing that.
Yeah.
But that isn't the whole picture. There's a lot more picture to that.
Mm.
The Hurst software that's developed by David Hickson.
David who?
David Hickson. He's one
Very
of our. Is it Hickson? Am I pronouncing that right? Yes, I think so. He's followed Hurst method.
Yeah.
To work out where you're at in cycles and do them, and it allows for a bit of fluctuation around things.
Okay.
I think he does use these periods,
Uh-huh.
and so it will be doing it. But this is the best evidence I've seen that there's something deep going on in the share prices. This is IBM, but it's equally going to apply to the other companies. You know, they will probably have exactly the same ones in them.
But this one is clearly harmonic.
Yeah, it's quite clearly. We've got the harmonics theory typical structure with 2, 2, 2, 3, 2. That's what happens all the time. So that's a little one on its own.
Yeah.
It's
fascinating.
It's
And like you say, we may find this in other stock prices.
yes, it'd almost certainly be very similar in other stock prices. Yeah.
Yes.
Yeah.
And quite a bellwether stock IBM is, and such a large one. So that's significant that we could use this as an example.
Yeah.